Okay, so this one, you've got a function that's a fourth degree that's opening downward because it's a negative. I lost my problem number sheet. All right, so it opens downward. And you want to try to find the biggest rectangle that you can stick in there. Okay, so the function is y equals 20 minus x to the fourth power. So however far over x we go, the point up here is 20 minus x to the fourth. So like if I go over 1 unit, then going up would be 20 minus 1 to the fourth. If I go over 2 units, then it would be 20 minus 2 to the fourth, and so on. So if I don't know how far over I'm going to build my rectangle, this point here is going to be x, comma, 20 minus x to the fourth. And this point over here and up, all right, is also like, it'd be a negative x, but then still you'd have to plug that in, 20 minus, and then x to the fourth, because you're going up that high. All right, so this length here, just in terms of absolute distance, would be an x plus an x, or this distance is 2x. This height is 20 minus x to the fourth. We want to maximize area. Area is length times the width of the rectangle. The width of the rectangle is 2x, and the length is this 20 minus x to the fourth. That's how high it is. And it's as wide as 2 x's. If I distribute, I get 40x minus 2x to the fifth power. Multiply like bases, add the exponents. Right? We want to maximize. So anytime you start saying about maximizing or minimizing, you're taking a derivative, setting the derivative equal to 0, and then solving. So derivative of 40x is just 40. Derivative of negative 2x to the fifth, bring the power down, decrease by 1, and now solve for x. So factor at this point out of 10. Inside parentheses is the difference of two squares, because difference means subtraction. 4 is a square, 2 times 2, opposite signs. X to the fourth, x squared. Set each factor that has an x in it equal to 0, because you're trying to solve for x, not the number 10. Get the x squared by itself, so I'm going to add it to both sides here, and then hit it with a square root. Now, normally you put a plus or minus in when you hit it with a square root, but because x is a distance, we're only looking at the positive length. Okay. On the other side, if I solve for x squared equals negative 2, and then hit it with a square root, you now have a negative under the radical, which means it's an imaginary number. And we're not doing imaginary things. So for right now, I know one of my critical points is at square root 2. That's this distance here. Like from here to here is square root 2. All right. So I want to see, is this going to give me a maximum area or a minimum area? So this is where I pick a point on either side. Now you can't pick any random point because you can't go smaller than 0 on your x. You can't have a width less than 0. And as big as you can go, you can't go super big either, because your height can't be a negative number. So like I can't plug in x equals 10 or have 10 as my ending point, because 10 to the fourth is like super huge, and 20 minus super huge isn't going to work. I can't have a negative length. But if I think about it, if I let x equal like 2 to the fourth, that's 16. 20 minus 16 is reasonable. If I do 3 to the fourth is 81. 20 minus 81 is a negative height. So it's got to be less than 3, but a little bit bigger than 2. So somewhere over here between 2 and 3 is where my cutoff point is. So if I'm doing my sign chart on my derivative and I wanted to see is it increasing or decreasing, I plug a number between 0 and 1, or 0 and 1.41, that's what square root of 2 is, back into my derivative. Here's my derivative formula. And I see is it a positive number or a negative number. So if I plug in the number 1, a prime is equal to 40 minus 10 times 1 to the fourth. That's a positive number. I don't care what it is, but it's positive. Then I pick a number between radical 2 and somewhere between 2 and 3. So I'm just going to pick 2. Put it back into the derivative. So 40 minus 10 times 2 to the fourth. 40 minus 10 times 16. I don't really care, again, what the number is. I'm just seeing that it's negative. So if you're increasing and then decreasing, that radical 2 is a maximum. So you're maximizing your area, all right? And then to find the height of this rectangle, so we plug in for y equals 20 minus square root of 2 to the fourth. 20 minus the square root of 2 to the 4 is 16. 20 minus 4 is 16. So this piece right here is radical 2, but I need 2 of those to measure out the distance of the rectangle. So 2 radical 2 by, and then the height is 16. So this is the width, this is the length. What he showed was you can take the second derivative. All right, so the second derivative of what I have up here with the stars around it. So if I take the second derivative of it, the 40's gone because the derivative of a constant is 0, and then bring down the 4 and get negative 40x to the third. And if you plug your critical point of radical 2 in for x, and it's a negative number, that means it's opening downward. So in this case, negative 40 times radical 2 to the third, whatever that number is times a negative is going to be a negative result. And if it's negative, it's concave down. And if it's concave down, then your point of radical 2 is sitting up there at the top, which is a max. So your dimensions, back to your answer, should be that.